Okay, in this video we are going to continue section 7.1 and we're going to talk about a consumption matrix. But before we talk about a consumption matrix, let me remind you exactly what we've been dealing with. Now, if I had an example of this where you open up a business making plastic bottles, okay? Now, if you remember our consumption rate from our last video, the consumption rate is basically the amount of internal consumption that a business has. So in order to make 100 bottles, it makes or it eats 5 bottles. So that means if I set up a little problem to find the consumption rate, my consumption rate would be 5%. Okay, so this is my consumption rate. And that's what we talked about yesterday, or not yesterday, but on the last video. All right. If you want to solve this problem, feel free to do so. Go ahead and pause the video right now. Okay, hopefully you already did it, and the answer is that. So the answer was 10,527 bottles, so hopefully you got that right. All right, so let's go into a consumption matrix. A consumption matrix is a matrix that displays the consumption of a company in a matrix format. Pretty simple. So what's it talking about? All right. For a battery division of a company to produce 100 batteries, it must use 3% of its own batteries. Now, we kind of built off of that question from the last video, but here's what I want you to kind of observe. And I'm going to try to do this to where you can see it. Where now we're dealing with batteries, and we're also now dealing with motors. So our battery company is now producing motors at the same time. Okay, so now we have to put all of this information into a consumption matrix. Now we're not just using we're not just using one rate anymore. We are now going to be using 4. We got to put something here. We got to put something here. Oh, you can't see it. All right, hold on. Let me just do it here. You got to, we're putting something here where that flower is. We're putting something there. We're putting something there. We're putting something there. So we're actually dealing with 4 rates that we have to figure out. Now, let's talk about the format of a consumption matrix. Okay. Now, notice that this consumption matrix is a 4x4 matrix. Okay. Now, with the labeling, notice that my producing is on the top and my from is off to the side. So the way that you read this, and let me kind of clean this up a little bit. In order to produce, now notice our first problem here. We're producing batteries. It says producing batteries, okay? So that means when we're talking about this consumption matrix, we're going to read it up and down. So we're producing batteries. So that means we're not producing motors. So what I'm going to do is I'm going to get rid of my motor column for the moment, okay, because we are producing batteries only, okay. But notice that it's from its own batteries. So when it says from its or of its own batteries, that means where it's coming from, which means you would reading it to the right. So basically it's like Battleship. You work down as you work across, and it comes together right here for batteries. All right, moving on. For every 100 batteries produced, one motor of the batteries or one motor is required from the motor division. So once again, we're still producing batteries. Okay, so that means this motor column is taken away. We don't need that. And it says is required from the motor division. So we're reading that way. And if you notice, motor is your second row, 0.01. All right, moving on. And feel free to pause this anytime just so you can look again. All right, now for every 100 motors produced. Okay, now we're producing motors. All right, so now we're producing motors, and I kind of wrote that kind of sloppy, so 8 batteries are required from the battery division. I think my creative pen probably won't work here anymore. So for every 100 motors produced, 8 batteries are now required from the battery division. So that means we are now producing motors. So that means the battery column is no longer needed when we're filling out our consumption matrix. And so now 8 batteries are needed. So when we read it this way, battery to motor 0.08. And hopefully by now you pretty much picked up the pattern here for the motor division to produce 100 motors. So motor division to produce, we're producing motors. So once again, the battery column is gone. It must use 4% of its own motors. All right, so that means the from right there, which is 4%. Okay, so basically what we have here is four consumption rates written in a matrix. Okay, so if I wanted to ask a question that looked like this, a company produced 230 motors. What is the internal consumption from the battery division? Well, if you remember back from yesterday's video, there's two formulas that you can deal with, and that is this. We have the big P minus little p times big P equals D, or we have little p times big P equals IC. Now remember, the question is asking for what is the internal consumption. So since we're wondering what the internal consumption is, we're going to be dealing with this formula right here. Okay, so using this information here, we're going to go ahead and plug in all here. We're going to plug in this stuff. So 230 motors would go in for the production. Now remember, we're looking for the internal consumption. Now the question is, what consumption rate do we deal with? Okay, now let's see here. It's saying it's producing 230 motors. All right, so we're producing motors. So the battery column is gone. Okay, what is the internal consumption from the battery division? Okay, so we're producing motors, which means we read it this way. Okay, and from the battery division, which means we're going to read it this way. Okay, so we're looking for from the battery. Oh, that's 0.08. Okay, so when we get this information into a formula, we're going to take 0.08. Now, it's going to be hard to see that. Nope, that's not what I was trying to do. We're going to take 0.08, and then we are going to put it into where little p is. So if I was to do the math, it would be 0.08 times 230, which gives us 18.4. 18.4 batteries. Okay, pretty simple. Now, if I was going to ask another question of, okay, let's just do a follow-up question of, if there was 230 motors produced, you know what? Scratch that. I don't even want to ask that question. Let's move on. All right. Last way that a consumption matrix can be displayed is in a digraph. Now, remember, a digraph is where you have arrows pointing to different vertices. Now notice that in my matrix I'm dealing with batteries, I'm dealing with motors. Notice that here's my battery vertex, here's my motor vertex. So all that information is already in my digraph. Now each excuse me, each edge represents a consumption rate. So like for example, if I was to say let me represent this, meaning I am producing, let's say I'm producing batteries, okay? So if I'm producing batteries, I'm not even going to pay attention to the motor, okay? But let's say if I want to figure out how many, the battery to battery situation. So that means producing batteries from batteries. Then I'm going to erase that because I'm paying attention to 0.03. Notice what we have, 0.03 right there. Okay, notice it's a loop, battery to battery. Now the thing that throws people off is when you're dealing with something like this, where you're producing batteries from the motor division. Now remember, from the motors, that means there's going to be an arrow pointing to the batteries from the motors. And if you notice, it is right here. Okay, that right there. Now if we were to keep going here, let's kind of clean this up a little bit. Let's say if we were going to do producing batteries from the motors, notice once again, we're producing motors in this case. So that means we're paying attention to the edge pointing to the motor from the battery division, which would be right here, 0.08. Okay, and lastly, see if I can move this. And by process of elimination, the 0.04, hopefully you got it by now, 0.04 is right there. So let me know if you have any questions. Other than that, hope you understood it.